Hello everyone, welcome to the lecture series on machine learning. In today's lecture, we are going to learn about logistic regression. So, let's get started. First, let's understand what logistic regression is. Logistic regression is actually a machine learning algorithm that is used for classification, and mainly it is used for binary classification where there are two possible outcome classes. For this lecture, we will understand logistic regression using binary classification, and of course, it can also be extended to handle multi class classification. Binary classification means there are only two classes, possible two classes, outcome classes, and multi-class means there can be multiple classes. So, what are the possible outcomes in classification, especially when we talk about the binary classification? For example, for a person or an object, we may have two possible outcomes. For a student, the decision can be pass or fail. For a customer, the decision can be whether the customer will buy some certain product or not buy. So these are two class problems where we can have classes like yes, no, true, false. If we are checking for the disease for patient, then disease or no disease. So there can be two classes, and this is called binary classification. Let's remember one important point here. We have already studied linear regression, right? In linear regression, we studied that the model predicts continuous numeric value. For example, it can predict the price of a house, the price of a stock, or the marks of a student, right? May get. So these are the continuous numeric values. But logistic regression is different. Logistic regression predicts a probability, and based on that probability, it decides the class. So we will see how this probability is calculated and how it is converted into the final class. Everything we will study. So the basic idea of logistic regression is very simple. Based on the given data, it tries to determine which category a particular person or a thing belongs to. And so the logistic regression algorithm takes the particular object that we want to classify and puts it into appropriate class. And it learns from the past data that we use to train the model. So then when we give it a new value or a new data, it uses what it has learned to predict its class. So now we know that how machine learning works, right? It always predicts something based on the historical data that we have trained with. So this is a simple idea of logistic regression. Okay, so this is the simple explanation of logistic regression, and now let's understand it in a little more detail. Let's understand logistic regression with a simple example. Imagine that a teacher wants to predict whether a student will pass or fail. Now, if a teacher has to predict whether a student will pass or fail, the teacher may check many parameters about the student, right? For example, how many hours does the student study? What is the student's attendance? What marks did the student get previously? Has the student completed all the assignments? So, all this can be important factors for predicting whether a student may pass or fail. And in the same way, our machine learning model, the logistic regression algorithm, will also learn from the previous student data. And it will have data about previous students. From this data, it will learn the pattern, and based on those patterns, it will predict whether the student will pass or fail. The logistic regression model calculates a probability, and probability will always be between 0 and 1, right? We all know that. So depending on the student study hours, because we have taken this example, so depending on the student study hours, attendance, previous marks, assignments, and other factors, the model calculates a probability. For example, suppose the model gives you probability 0.85. That means that there is an 85% probability that the student will pass. And similarly, if the model gives a probability, let's say 0.20, that means there is a 20% probability that the student will pass. So in other words, we can say that 80% chances of student will fail. So that is the failing prediction. Okay, so suppose we have a scenario where the student has a higher chance of um, higher chances of passing. We are taking this scenario. So here the attendance is 90%, previous marks are 78%, and student has completed 9 out of 10 assignments. Also his study hours are 8 hours per week. So his these are his parameters. So when the model calculates the probability using these factors, suppose it gives us a high probability, and in our example we will calculate the exact probability using the logistic regression formula. Here we have just taken the random value. This is not the correct answer, actually we have just given random value. We are just assuming because we want to understand, because we don't know that what is the exact formula yet, right? So yes, so based on these parameters, let's model has predicted 0.80, and it falls under the class pass. So based on the final probability, the model will predict the that the student will pass. Similarly, let's take another scenario where the student has a higher chance of failing. And again, the model will look at all the available data such as student hours, attendance, and all those, right? So after performing the calculation, the model will get a probability. Let's say it's a 0.20. So if the probability of passing is low, the model will predict that the student will fail, right? So we will see the complete calculation shortly. Now let's see what kind of data the machine learning model has for particularly this example. We have already trained our model. For example, it may have data like this, like student 1 studied for 9 hours per week, the attendance 92%, previous marks 82%, assignment completed all 10 out of 10, and along with all this data, we also gave the model a label. The label tells the model the final result, and here it is pass, right? So this column is actually a label column. So in the same way, we have data for many students. Here we have total 10 students data. So this is our training data, and when we give a new students data to the model studies this training data and uses the pattern it has learned to make a prediction. So this is how machine learning models work, and now we know that. So, if we want to understand the complete process in short, first we have student data, right? So first we give the student data to the logistic regression model, and we use this data to train the model, right? The model performs some calculation based on the learned coefficients and the values and patterns, and then it calculates a probability. So after we get the probability, we apply a threshold. For example, in this example we are using threshold of 50% here. So if the probability is greater than or equal to the zero point 0.5, the prediction is a pass, and if it is less than zero point 0.5, then the class is fail. So this is in short we can keep in mind for the logistic regression. So this is simple example of how a logistic regression model makes a prediction using previous data. Now let's continue with same example and understand it in more detail with maths. So now we will actually see how the model makes the prediction and how does it perform the calculation, what formula does it use. Also we will understand all of this using the same example. Okay, so let's start. The first thing we need to understand is that the logistic regression model has an equation. So the equation is this: z is equal to b0 plus b1 plus x1. Because we have taken example of student, hence we have written ours. Otherwise it's a general formula is b0 plus b1 into x1 plus b2 into x2 plus b3 x3 plus b4 x4, and like this, like that. So this is the formula. So now z is actually here, the z is the linear score. We call it a linear score, which can be any real number, right? We are going to calculate it. And b0, this b0 is the intercept or the starting score also, we can say. And all these b1 b2, like b1 b2 and all this, are the coefficients, and these coefficients are learned by the model from the training data. So basically this formula is used to calculate the linear score z, this z. Once the value of z is calculated, step 2 comes, and in step 2 we convert the z score into the probability, and for this we use the formula p is equal to 1 upon 1 plus e raised to minus z, and this is called the sigmoid function. We call it sigmoid function, and it converts any value of z into a probability between 0 and 1. After calculating the probability, now the step 3, once we have calculated the probability, we apply a decision rule here in the step 3. If the probability is greater than or equal to zero point 0.5, then the predicted class is pass, right? Class 1, also we can say class 1 or a pass. And if the probability is less than zero point 0.5, then the predicted class is class 2, that is fail, right? Yeah, we have taken example of pass and fail, hence class 1 is pass and class 2 is fail. So for our example, if the probability, just for the understanding purpose, if the probability is 0.80, that means that the model estimates 80% probability that the student will pass. And if the probability is 0.20, means the model estimates 20% probability that the student will pass, and therefore there is an 80% probability that the student will fail, right? So we are specifically talking about the probability of passing here. Now let's put the actual values into the formula and see how the prediction is calculated. For our first scenario, we have the following values: study hours 8, attendance 90% or 90, we can say 0.90, previous mark 78 and 78%, and assignment 9 out of 10. So these are the input values that we are giving to the machine learning model. So as we know, the very first step is to calculate linear score y. So for this, we use our formula. As we know that z is equal to b0 plus b1 x1 plus b2 x2 and so on. So now we assume that the model has already learned its coefficients from the training data, and here we have all the values. The model has calculated these values internally during the training, right? So for example, here we are taking the example of b0 is equal to minus 4.0, which is the intercept. Then b1 is equal to 0.60, and like that we have all the values. So these values are learned by the model from the training data actually. Now let's put all the values into our formula. So here we have z is equal to minus 4 plus 0.60 into 8, and like that we have put all the values in the formula. And after the calculation, after calculating, we finally got 9.44 value for the z, that is linear score, right? We got value of z is equal to 9.44. So linear score is z is 9.44. Now in step 2, we convert this score into the probability, and for that our probability formula is this: p is equal to 1 upon 1 plus e raised to minus z. And if we put all the values here, finally we got p is equal to 0.99992, which is approximately 99.99% or almost we can say 100%, right? So the model estimates an approximately 99.99% probability that the student will pass. And now in the step 3, we apply the decision rule. A probability is 0.99992, which is of course greater than zero point 0.5. That is approximately 1, which is greater than zero point 0.5. So therefore the predicted class is pass, right? So this is how logistic regression model actually works, and it calculates a score, linear score, then convert that score into a probability, and then uses the probability to predict the final class by applying the decision rule. Now let's take the second scenario as well. Again we will put all the values into, we have these values, we will put all the values in the formulas, and after performing all the calculation, suppose we got linear score is 1.06, and now we will put this score of linear score into the probability formula, and we got this 0.22, which is 22%, right? So and when we apply this value in the decision rule, we can see that 0.22 is less than zero point 0.5, hence predicted classes fail, right? So, this is all about logistic regression. We have seen how logistic regression works mathematically. We also understood its use for binary classification. We saw how the model uses the training data, calculates a linear score, converts that score into probability using the sigmoid function, and finally applies a decision rule to predict the class. So, this is how logistic regression mathematically works and how it is used for classification. So we'll meet in the next video. Till then, bye bye, take care.